Welcome to solverfy.
This is the answer to Chapter 27, problem number 16 from the Smith Organic Chemistry textbook. And in this problem, we are asked to consider two 2+2 photochemical cycloadditions. And so photochemical, of course, meaning light is the driving force here rather than heat. And so we do just need to remember that in the case of a photochemical 2+2 cycloaddition, the cycloaddition is going to be superficial. And so what that means is we have trans chemistry, trans stereochemistry in the starting material here. So I will underline it in red. And so we expect to see trans stereochemistry in the final product. And so let's take a look at that. So we should know by now 2+2 cycloaddition. So the electrons from this double bond will go to make a new bond, as will the electrons from this double bond. So two new bonds, cycloaddition. So we will get a ring at the end. And since it's 2+2, we're going to end with a four-membered ring here. So there is our four-membered ring. We have our two methyl groups from the starting material on the right. And then from the starting material on the left, we have these two benzene rings. And so, since they were trans to begin with, and we're talking about a superficial cycloaddition, they need to be trans to end with. And so C6H5, they have a trans relationship here at the end. And of course, we will also see the enantiomer. So they'll still have a trans relationship, but as far as which is which, they can actually be switched. So the top one could be dashed and the bottom one wedged, as long as they're trans to one another. And so we're going to expect the same thing on part B. So when we look at B, the thing to look at is this nitrile and this hydrogen are cis to one another. And so we expect them to be cis to one another in the final product as well. So our electrons there will make a new bond, and our electrons there will make a new bond. Again, we're forming a new four-membered ring from this 2+2 cycloaddition. So here is our six-membered ring that we started with. Ketone, of course, is not involved in this reaction, and so it will be unaffected. Oops, it's ugly. And so here is our new four-membered ring. And here is our nitrile. And as we said, it started cis to this hydrogen. So it's going to end cis to this hydrogen. So there they are. And just like in A, we'll also see the enantiomer. So they could also both be dashed instead of both being wedged. But they do have to be both one or both the other because they have to have that cis relationship. And so that is the answer to Chapter 27, problem number 16.